What'd you say to me?
Okay, so the title of your paper is Basic Geometry Vocabulary. Basic Geometry Vocabulary. And don't forget to put your name on your paper. So remember I told you we take notes on note cards. So everybody gets 2 note cards today. Take notes on. So you got your piece of paper where you're going to do the problems on that paper. And then you got your 2 note cards. All right, so the first note card for today is number 2. Not surprisingly, because we had number 1 the other day. And the title is Angles. So I'm going to be over technical here, like mathematicians usually are. An angle is made by 2 rays with the same endpoint. An angle is made by 2 rays with the same endpoint. So if you're going to understand this, you need to know what a ray is. A ray is kind of like a line, except it goes forever one way, but it stops on the other end. So a ray is sort of like a line, but a line goes forever both ways. And a ray goes forever just in one way, and it stops on the other side. Okay, so this is a ray, and then that point there where it stops is called the end point. And then an angle is made up of 2 of these that have the same end point. So if I'm going to make an angle, I got to start at the same place and go off in a different direction. So there's one ray, and then there's another ray, and those 2 rays have the same end point, and so together they're called an angle. Okay, so that's what an angle is. An angle is made by 2 rays with the same end point. All right, then the end point together is called the vertex. So I'm going to say that that's D. And then over here, let's say we have an A. And over here, let's say we have an E. So those are some points that are on the angle. And the name of this angle then is angle ADE. Or you could call it angle EDA. So when you name an angle, you use 3 letters, and the vertex has to be in the middle. So since D is the point or the vertex of this angle, that's why I put D in the middle. And that tells you what angle it is. Okay? But usually we think about how big the angle is. So the measure of the angle is the amount of rotation from one ray to the other. The measure of the angle is the amount of rotation from one ray to the other. So what I mean by that is you would start here and then see how far you'd have to rotate to get to there, and then that tells you how big the angle is. So if you have to rotate a lot, then it's a large angle, but if you only have to rotate a little bit, then it's a small angle. So the size of the angle has to do with the rotation. Okay, so that's what I mean by the measure of the angle. Okay, then there are different types of angles. One of them is called acute, and an acute angle is an angle that is less than 90. You've probably heard that word before, but we're just making sure. So an acute angle is an angle that is less than 90. And then, of course, a right angle is a 90-degree angle. And that looks like a perfect corner, right? A 90-degree angle is a perfect corner. So if it's less than that, it's acute. If it equals that, it's called a right angle. And then if it's larger than that, it's called obtuse. So obtuse is an angle that is greater than 90. And then the last word for this note card is straight. And a straight angle is two rays that make up a straight line. Hey, how's it going? Yeah, that's perfect. Thank you very much. So straight is two rays that make a line. So the way you do that is you have a ray going this way. So there's one ray. And then you have another ray going this way. And then if they together make up a straight line, then they're called a straight angle. All right, so if you've got one ray and then another ray, and together they make up a straight line, then it's called a straight angle. That's kind of weird. Usually you just look at it as one line together, but you can look at the two halves and see the two rays and then think of it as an angle. Now, when you do that, when you rotate half the way around, well, first of all, if you rotate all the way around, that's 360 degrees, right? You've heard somebody did a 360. That means they rotated all the way around. So if you rotate half the way around, that's going to be 180 degrees, because that's half of 360. So if you rotate half, that's called a 180. All right, one other thing I want to mention on this note card is you can use 3 letters to name an angle, but sometimes there's a number inside the angle, like that. And then that's another way to name it. So this could be called angle 2 as well. Or on a different angle, it might be a 4 in there, and then that one would be called angle 4. So two different ways to name an angle. You can use 3 letters, or sometimes there's a number in there, and then you can use the number to name the angle. Okay, so that's all about angles. Everybody okay with note card 2? All right, so the next one is note card 3. Oh, and one other thing you want to do, make sure you put your name on your note cards as well. Don't put Mr. Early, that's my name. Put your name down there. Sometimes people get in the habit of copying things down. So make sure you put your name. So in case you lose it. So the first word on this note card is parallel. And parallel is 2 lines that do not intersect and are on the same plane. Two lines that do not intersect and are on the same plane. There's a couple of vocabulary words within that definition. So, of course, intersect means hit each other. So if they don't intersect, that means they don't hit each other. And then a plane is a flat surface. So if you look at the top of your desk, and except a plane goes on forever. So look at the top of your desk, and then if you go forever that way, and forever that way, and forever this way, and forever this way, that whole flat surface, that's called a plane. Another possibility would be the board up here, as long as it extended forever. Okay, so parallel lines are lines that don't intersect and are on the same flat surface. And you've seen these before. Of course, they look like this, right? So those lines are parallel because they never hit, and also because they're both on the board. So they don't intersect and they're on the same plane. So that's kind of old stuff. But then there's this word that's probably new for you. This is the word skew. And skew are 2 lines that do not intersect. And are not on the same plane. Skew is 2 lines that do not intersect and are not on the same plane. So that's kind of tough to draw because the board is a flat surface. Okay, so here's 2 lines, the pen and the marker. So the marker goes this way, right? And the pen goes this way. And those lines are never hitting each other. But they're not on the same flat surface. Like this marker is on this flat surface, and this is on this flat surface. So these are called skew lines because they never hit each other, but they're on different planes. So parallels like this, if they're on the same flat surface, and skew is like this, if they're on different flat surfaces. Okay, so that's a new one. You're used to the word parallel, but probably not used to the word skew. All right, next we have coplanar. And coplanar means on the same plane. So those 2 skew lines were not on the same plane. So they were not coplanar. But these 2 lines are both on the board. So they're on the same plane, so they're coplanar. And then collinear means on the same line. So if you have a bunch of points that are all in a row, they're all on the same line, that's called collinear. And if they're on different lines, if they're like scattered around, then they're not collinear. So coplanar means coplanar means same plane, and collinear means same line. So the prefix co means same. All right, so that's 4 vocabulary words for you. So we're going to, like I said, we're taking notes on note cards this year, and you're allowed to use these on quizzes and tests. So we want to make sure you don't lose them. So make sure you put your name on them, first of all, because if you do lose them, maybe can get it back to you. Yes, Charlie?
So the name of this card is like a continuation of Angles?
No, it's different. I mean, if you really want a title for it, you could say parallel and skew.
Okay.
But I didn't think that was necessary for sure for everybody because of the words there. But some people like to have titles on every note card, so that's fine. So make sure your name's on your note card so you don't lose it. But also, I'm going to have you hole punch the note cards. I'm going to pass out the hole punch. And then I'm going to give you a ring. And you can put all 3 note cards in the ring and then put the ring in your binder. That way, once we have 10 of these or so, you'll be more likely to hold on to them. And it's important to hold on to them because you're allowed to use them if you have them. Of course, you can't use them if you don't have them on quizzes and tests. So hole punch your note cards and then put this ring on them so we can stay organized. Yeah. So here's a blank one, first of all, and it was number 1. And then, yeah, you could watch the video, or you could just borrow one from somebody. But I also explained how to do some of the problems on the video too, so just so you know.
I was absent this week.
Oh yeah, you get you. So hole punch your note cards. And then put them in your ring. Everybody have your phone back here. Put in the ring. Challenging class. Exhilarating. Oh yeah, remember I'm taping class every day, so if you like maybe tomorrow you're like, man, that was a great lesson, and the joke was hilarious, you could watch it again. I mean, it would be maybe in the evening, like you sit down and you're like, what can I do for fun? And then you realize, I could watch Mr. Early teach geometry again. And you just like open that up, and you'll probably do that. I know.
The peak of 21st century.
Yeah, try to contain yourself. I know it's hard to, yeah. I know it's hard to not be super excited about that. Yeah. You gotta have some kind of big form here in class. Yeah, it's good. Someone's gonna have to. Hole punching, organizing our note cards. thanks for your patience. Get started on the worksheet as soon as we're done. All right, so now we're ready for the sheet of paper. And I said this earlier, but the title is Basic Geometry Vocabulary. So it's time to come back to the front, please. So the title is Basic Geometry Vocabulary. And we're going to start with number 1. And the question says, so let me read the question to you. It says, why do you think a plane, so that's a flat surface, why do you think a plane has to be named by 3 points that are not on the same line? So earlier in the class we talked about the name of an angle. We said you use 3 points to name an angle. You also use 3 points to name a plane. And the question is, why do you have to use 3 points that are not on the same line? Okay, so in order to get at that, I want you to draw 3 points that are on the same line. And then separately, I want you to draw 3 points that are not on the same line. So these 3 points are collinear. They're on the same line. And these 3 points are not collinear, because they're not on the same line. So when you name a plane, just like with an angle, you use 3 points. And you can't use these 3. And the reason why is there's a bunch of different flat surfaces that goes through these 3 points. So here's a flat surface that hits those 3 points. Here's another flat surface that hits those 3 points. Here's another flat surface that hits those 3 points. So there's lots and lots of flat surfaces that hit those 3 points. So if you use those 3 points to name it, you wouldn't know which one you were talking about. Kind of like if you just called somebody by the last name Smith. There's a lot of Smiths, so you don't know which one you're talking about. So you have to be more specific. So the reason why you can't use 3 collinear points to name a plane is there are a lot of planes that go through 3 collinear points. So the question was, why can't you use 3 collinear points to name a plane? And the answer is because there's a lot of different planes that go through those 3 points. So it wouldn't be specific enough. Okay? Number 2 has a picture in it, so I'll draw. You do not have to draw this picture. And it has a bunch of angles in the picture. So raise your hand if you can tell me how many angles you see in this picture. How many angles do you see? Yeah, Connor?
2.
Definitely 2. He's seeing that one, probably, and this one. Sure.
I see 3.
All right, and then there's the large one as well. Good. Okay, so in this picture, there's 3 angles. The big one and then the 2 smaller ones. All right, now we already talked about in the note card that you use 3 letters to name an angle. But some people might be tempted to just call this angle angle C. why couldn't you call this angle angle C? Yeah, Judah?
Because it could go for all three of them.
Yeah, you wouldn't know which one you were talking about, right? If you just said angle C, you wouldn't know if it was that one, or this one, or the large one. So instead, you call this one ACB. And if you use those three letters, so you use three letters to name an angle, just like we said on the note card. If you use those three letters to name the angle, then you know specifically which one you're talking about. Okay, so the question on number 2 is, why can't you name the angle angle C? And the answer is, if you just called it angle C, we would not know which of the three you were talking about. So again, it has to do with being specific. So in number 1, we couldn't use these 3 points to name the plane because you wouldn't know specifically which plane we were talking about. And over here, you couldn't use angle C simply to name it because then you wouldn't know which of the 3 angles you were talking about. So that's why we use 3 points to name an angle, and that's why we use 3 non-collinear points to name a plane. Okay, so that brings us to number 3. And number 3 talks about how many points you need to make a single line. So first of all, I want you to draw 1 point. This goes on number 3. If you just have 1 point, there's a lot of different lines that go through that point. There's this one, there's diagonal one, there's ones 3D coming in this way. So there's lots and lots of lines that go through 1 point. But then, if you just have another additional point, now there's only 1 possible line that goes through those 2 points. That's actually kind of amazing. If you have 1 point, there's lots and lots of lines, thousands. But if you have 2 points, it's only possible to draw 1 line that goes through those 2 points. So the way we say that is we say 2 points determine a line. And that's a fancy way of saying if you have 2 points, there's only 1 line that you can draw through those 2 points. If you have 1 point, there's a lot of lines you can draw through the points. But if you have 2, there's only 1 possible line. So that's 2 points determine a line. And because of that, we use 2 points to name a line. We'll talk about that tomorrow. Okay, then if you have 3 points, then there's only 1 possible plane that can go through those 3 points, unless they're collinear. If they're collinear, there's a lot of different planes. But if there's 3 points, so the way we say that is 3 points determine a plane. So that's just a fancy way of saying, actually I want to add 3 non-collinear points determine a plane. Sorry about that, squeezing that in. If you have 3 collinear points, like over here, there's a lot of different planes. If you have 3 points that are not in the same line, they determine just 1 plane. I don't know if you've ever noticed this, but a stool never wobbles. And that's why, because those 3 points at the bottom of the stool, they make a flat surface. So on a flat surface. But if you have 4 legs, it could wobble because 4 points could be on a different plane. All right, 5 through 10 are true, false. And 5 says all right angles are congruent. So now it gets to the point where you probably need to look at it. So let me pass out the paper. We're on the back. Oh, now would probably be a good time for the joke, too.
Yeah, that was good.
And so you maybe you heard this yesterday. So the joke is, how does the man in the moon cut his hair? How does the man in the moon cut his hair? Eclipse it. It's pretty funny, huh? I knew you'd think it was funny. Yeah,
Yeah, it's actually pretty funny.
yeah, yeah. It's short for he clips it.
Got me the wrong.
Oh, sorry. Sorry about that. There you go. So one of the reasons I tell bad jokes like that is then sometimes the students are happy when I start teaching math again. That's really bad if the jokes are so bad that you'd rather do math. But that one was pretty bad. Did I miscount? Or you guys are only supposed to keep one per 2 people, right? So that's not bad. All right, so for number 5, it says all right angles are congruent. So let's draw 2 right angles. Remember, a right angle is a perfect corner. So there's 2 right angles. And the word congruent means the same size and shape. So are these 2 right angles, are they the same size and shape? They're definitely the same shape, right, because they're both angles. And then also they're the same size because they're both 90 degrees. So these 2 right angles are congruent. They're the same size and the same shape. Is it possible to draw different right angles that are different sizes? I mean, some people think, if you extend this out, it makes it a different size, but it's still 90 degrees. Okay, so it is true that all right angles are congruent, because it's not possible to draw 2 90-degree angles that are different sizes. Okay, so number 5 is true. Okay, number 6 says all acute angles are congruent. So here I'm going to draw a couple of acute angles. They just have to be less than 90, right? So let's say this one is 40 degrees and this one is 40 degrees. So there's 2 acute angles. Are these acute angles the same size and shape? Yeah, they are. Is it possible to draw different acute angles that are different sizes? Yeah, like this one could be 40 and then that one could be 10, right? So let's draw that. Here's a 40. And then a skinny one. There's a 10. So the picture on top makes it seem like acute angles would be congruent. Makes it seem like they would be the same size and shape. But then the bottom picture shows that they don't have to be. So it's sometimes true, right? Which means it's false. In geometry class, if it's ever false, then the overall answer is false. Okay, so for number 6, make sure you have these pictures down and make sure you put the word false. Now would be a good time. Okay, so let's see. I'm going to skip down to the picture. So 7 through 10, if you want a number 7 through 10 on your paper, now you could do that, but I'm going to skip down to number 13. So what we have to do in 11 through 16 is draw a picture. And that's what modeling. It says each statement below describes the relationship between some geometric figures, and then we're going to draw a model or a picture. All right, so for 13, there's a cursive N, and that means that it's a line. So we're drawing a picture to fit the description. So draw a line, and then put a cursive N by it. We'll talk about this more tomorrow, but when you name a line, you use a cursive letter. So there's the line, there's the N. And then next to that, there's a cursive T. And so that means there's another line. And they're supposed to intersect. So draw another line. The cursive T means that that line is called line T. And then they're intersecting right here. And the description says that they intersect at point P. So you put a P by that to show that that's where they intersect. All right, so what we're supposed to do is read the description and then draw a picture that goes with it. So we've got line N and line T, and they're intersecting at point P. So that's what number 13 is. Okay, now I'm going to go to 15. And there's a bunch of figures there. First of all, MN, GH, AB are not coplanar. So coplanar means on the same plane. So I need to somehow draw a picture that's not coplanar, which is a little bit difficult because that means it'll be 3D. And I'm kind of bad at drawing 3D, but here I'm going to give it a shot. So draw a rectangle. And then behind it, draw another rectangle. And then if you connect the corners, it kind of looks 3D. I'm not very good at it, but you'll feel better about yours if mine is bad, so that's not too bad. Mine is bad. So there's a 3D picture. Okay, now it's talking about MN, so that's a line segment. So we're going to start over here and call that M, and then call that letter N. So there's MN on the bottom front of the box. Then it's also talking about a ray, GH. So I'm going to have G be up here, and H be down here. And then ray GH goes there. And remember, a ray goes forever one way, but not the other way, so it stops at G. So there's ray GH. And then it's talking about line AB. So I'll put an A here and a B there. So there's line AB. Okay, so MN is the front bottom of the box. GH is the front right side of the box. And AB is going back. It's the bottom right side of the box. Okay, so we have those three, and they're not coplanar, which is true, right? Because these are in the front of the box, and the AB is on the side of the box. So they're not on the same plane. And then they're supposed to intersect at D. So they all hit right here at point D. So there's a bunch of lines intersecting at point D. Okay, just want to make sure I do all the tougher ones for you. It's hard to read number 12, so let me tell you what question 12 is. And actually, if you would write this on your paper, that would help me out. It's supposed to say TU and K intersect. So it just didn't print out correctly on number 12. All right, so go back and do 7 through 10, and the other ones I skipped, please.